Hey everybody, we're going to talk today a little bit more about lines in the coordinate plane. And the coordinate plane, remember, is just the graph, all right, the x and y axis and plotting points. But first, before we start working with that, let's take a look at all the different formulas that we've talked about so far. And remember, these are not given to you, so these are all things you'll want to memorize and understand the parts of. It might be a good idea to make some flashcards, but we'll talk about that. All right, so there's different types of equations of lines. We have the slope-intercept form is what we're used to using, which uses your slope and your y-intercept. Y equals mx plus b. That's your slope. The m, not the m with the x, just the m. And then the number by itself, the constant, is your y-intercept. Notice that you have to get y alone first. All right, so that's the biggie. If you don't have the slope, you'll need your slope formula. We use m equals because that's what represents the slope. y2 minus y1 over x2 minus x1. Or if you're on a graph, it would be rise over run. And always going from left to right. All right, and the y2 and x2, those are all just parts of a point. So if you have the first point, x1, y1, and then the second point, x2, y2. And it doesn't matter what order you go in. All right, you could start with the first point or the second point. It doesn't matter as long as you're consistent with the y's and your x's. All right, the point slope form, this is the other form of a line, which is the same as y equals mx plus b. It's just written a little bit differently. It's called the point slope form because if you have a point and the slope, you can easily write it. And that is y minus the y value in your point equals your slope times x minus the x value in your point. Okay, so again, slope is m, and then the y1 and x1 come from one of your points. All right, your y-intercept is where it crosses the y-axis. It's referred to as b. So this is your y-axis. So if you have a line, it'd be right there. Okay, if that's 2, that would be the point 0, 2, because the 2 is on the y-axis. It's in the y portion of the point. X-intercept is where it crosses the x-axis. So again, if that is 2, then that would be the point 2, 0. Notice if it's the x-intercept, your y value is 0. If it's the y-intercept, your x value is 0. All right, vertical lines are lines that run straight up and down. If we were looking at a grid, let's say we had our x and y axis here. It's only hitting the x-axis. It's not hitting the y-axis. So that's always going to be x equals some number. Let's say -2 in this case. Most equations have a y in them, but if it's vertical, it doesn't hit the y-axis, so there is no y. And the opposite's true with horizontal lines. A horizontal line is only hitting the y-axis. So there's no x in the equation. That would be just y equals 2 or y equals 5. All right. The thing to remember also with the slope of those, if it's a vertical line, there's no slope or an undefined slope. Whereas with a horizontal, there's 0 slope. There is a difference between 0 and no slope. Parallel lines have slopes that are congruent. They're the same. Perpendicular lines have slopes that are negative reciprocals, which again just means you change the sign and flip the fraction. So if it's -5/3, The line that's perpendicular to that would be positive 3/5, and so on. Okay, so those are all your formulas that you really need to know and understand. And let's do some practice with those. So write the equation of each line in the given form. Okay, so the line with a slope of negative 2/3 and a y-intercept of 12 in slope-intercept form. That makes sense. We're going to use slope-intercept form, which remember is y equals mx plus b. If they give you the slope and the y-intercept, that's what you would use. So it's just y equals negative 2/3 x plus 12. The next one gives you the slope and a point. So again, it makes sense to use the point slope form. And again, that is y minus the y value in your point equals the slope times x minus the x value in your point. I know that equation's a little bit harder to memorize because we're not used to it, but trust me, the more comfortable you get with it, the easier it'll be. All right, so this is our x1, y1, and this is our m. So it's y minus the y value in the point. So y minus negative 4 equals your slope, 6, times x minus the x value in the point. But typically we're not going to leave two signs, so instead of minus negative 4, we'll just write y plus 4 equals 6 times x minus 3. And that's point slope form. Now what you could do if it said right in slope intercept form, you could distribute the 6 through and then subtract the 4 over, and you could easily put it into slope intercept form to graph. Okay, here's some more on the next page. The line through the point 0.5 with a slope that's perpendicular to 6 in slope intercept form. So that means in the end we want it to look like this. Well, they didn't give us the y-intercept though, so it would make sense. This is what I was talking about before. To start, since I have a point and the slope, let's use point slope form first, which again is y minus the y value in your point equals the slope times x minus the x value. And I know I keep repeating that, but trust me, the more you say it, the more you write it, the easier it's going to be. All right, so we have our x1, y1. Our slope, though, it says perpendicular to 6. If it was parallel to 6, 6 would be your slope. Well, if it's perpendicular, we have to flip it and change the sign. So 6 over 1 becomes negative 1, 6. All right, so there's your m that you're using. So y minus the y value in your point equals the slope, negative 1, 6, times x minus the x value in your point. That's in point slope form. It wants it in slope intercept form. So I'm just going to manipulate this a little bit. Negative 1, 6 times x is negative 1, 6x. Negative 1, 6 times 0 is just 0, so we don't need that. Now the only thing we have to do is get y by itself, so we'll add 5 to both sides. So your equation y equals negative 1, 6x plus 5. All right, the line through negative 6, 2 with a slope parallel to 7 in point slope form. All right, again, point slope form. Y minus the y value in your point equals the slope times x minus the x value in your point. Point slope. Here's x1, y1. Parallel to 7, so it's going to be the same slope. So y minus the y value, y minus 2, equals the slope times x minus negative 6, which we'll write as x plus 6. And you're done. If it said change it to slope-intercept form, then you'd solve for y, but you're done. All right, a quick review as well. Parallel lines have the same slope. Intersecting lines have different slopes. And coinciding lines have the same slope and the same y-intercept, which makes them the same line. That's all coinciding means. Everything coincides. All right, so determine whether these are parallel, intersect, or coincide. 3 and negative 3, those just intersect. I feel like they deja vu. Let me just double check. I feel like we went over these already. Tell me I didn't accidentally put them in twice. Sorry, guys. Well, whatever. A little extra practice never hurt anybody. Oh no, this was on page 22. So, well, it's a little different than what was on 22. Okay, so with this, we're going to add 4x. So it's 2y equals 4x plus 16. Divide by 2. Y equals 2x plus 8. Over here, I've got to add 10 to both sides. Y equals 2x plus 12. If those were the same, then those would be coinciding. They have the same slope, different y-intercept, so those are parallel. And if you ever wanted to check, you could just type them into y equals in your calculator together, and you would see that they don't intersect. All right, a couple more questions. Given the line negative 4x plus y equals negative 4x plus 2, determine if the point 46 is on the line perpendicular to that given line with the same y-intercept. What? All right, well, let's figure out what's going on. A line that's perpendicular to the given line with the same y-intercept. Okay, we can do that. So the slope, if they're perpendicular, we're going to change it and flip it. Same y-intercept, so 2. So our equation is y equals 1/4 x plus 2. Perpendicular slopes, same y-intercept. Now we want to see if the point 46 falls on that line, so we can just plug it in and check. So instead of y equals, 6 equals, instead of 1/4 times x, 1/4 times 4 plus 2. All right, so we'll leave this side alone. 1/4 of 4 is 1. And 1 plus 2 is 3. They're not equal, so no, that point's not on the line. And last question for today. Given the line y equals 5x minus 6, determine if the point 1, negative 3 is on a line that's parallel to it. So the same slope, so I know it's going to be y equals 5x. If the y-intercept's negative 8, so there's our equation. Let's plug the x and y in for it. So instead of y equals, negative 3 equals, instead of 5 times x, 5 times 1, negative 3 will stay. 5 times 1 is 5, and 5 minus 8 is negative 3. So is the point on the line? Yes. All right, so lots of good practice there. We'll be moving on and talking about more of this coming up. You will be having a quiz. But make sure that you're comfortable with all of those formulas and know the parts, because again, those are not going to be on your formula sheet. Okay. No practice to go along with this. Again, you will have a quiz coming up. Have a great day.